Scientists have found the most extreme example of one of the universe's mysteries. It is only the second example of a repeating fast radio burst with a compact source of weaker but persistent radio emissions. The discovery raises new questions about these mysterious objects. Fast radio bursts, or FRBs, are precisely what the name implies: an intense but short-lived burst of energy in the radio spectrum. They are powerful but fleeting bursts of radio waves, emanating from tumultuous sources in deep space, and release as much energy in a millisecond as the Sun does in many days. Over 95% of FRBs discovered so far have been detected just once and never heard from again. But a small amount repeats. The first FRB was only discovered in 2007 by astronomers at West Virginia University. It was lurking in radio telescope data gathered in 2001. Various origins have been suggested for FRBs, including neutron stars, gamma-ray bursts, black holes, star collisions, and magnetars, neutron stars that are magnetically ultracharged. But scientists have yet to pin down a precise cause of FRBs. Now, an international team of researchers, led by Dr. Di Li from the Chinese Academy of Sciences, has found FRB 190520. This peculiar FRB not only repeats, it has a second mysterious source of weaker radio waves between the more powerful bursts. It's a loud signal and background noise, all in one package. The discovery was reported in a paper published in the journal Nature. Of the 800 FRBs discovered to date, only 24 are repeating, and only one has a similar persistent radio signal. FRB 121102, the first repeater ever found. This second example shows that such association between an FRB and a radio source is not a coincidence, but a critical part of an FRB, and it brings up some important questions, said Casey Law, an astrophysicist at Caltech, and co-author of the paper. Are those that repeat different from those that don't? What about the persistent radio emission? Is that common? The team used the Very Large Array Telescope in New Mexico to pinpoint its source's location, a dwarf galaxy 3 billion light-years from Earth. Astronomers have only pinpointed the location of 19 other FRBs. Usually they have to rely on dispersion, a measure of how stretched out an FRB is when it reaches Earth, to estimate their distance from our planet. Much to the surprise of the researchers, the distance estimated using the dispersion of the FRB 190520 was 30 billion light-years from Earth, 10 times the distance pinpointed with the help of the Very Large Array. This new FRB shows that estimates using dispersion can sometimes be incorrect and throws many assumptions out the window, said Kshitij Aggarwal, a graduate student at WVU and co-author of the study, in an article for The Conversation. Why the dispersion of FRB 190520 is so much greater than it should be is a huge mystery. Was it due to something near the FRB? Was it related to the persistent radio source? Does it have to do with the matter in its galaxy? All of these questions are unanswered. Astronomers in this new field still don't know what produces FRBs, so every new discovery or piece of information is important. Hopefully, more answers will come from other FRB discoveries in the coming years. Thank you for watching. And please, don't forget to subscribe.